Hi everybody, and welcome. Today we're going to be taking a look at finding intercepts, zeros, and holes. So a little bit of review, but also some new terms that we are solving for as we work through our example questions here. So starting off with our notes, we're going to fill in the blanks, and from there we're going to jump into doing the actual practice questions here. So just reviewing domain of a rational function. So this is all real numbers except for those x's which make the denominator equals 0. And holes in a rational function, these are any factor that cancels out on both the numerator and denominator. Will create a hole in the graph at the x that makes that factor equal to 0. So as is the case here, sometimes you might have a hole, sometimes you might not. And that's something that we want to be careful of, and not just assuming that because there's a function that it's always going to have all of these things. Sometimes it might just be a nice clean function, no holes. And same thing as we go through and we try to solve for all of these. So just working through, a good place to start is just doing some factoring of the things that we can see. So x squared, 5x, and 6. So if we put that into a box, we should get 2 and 3 as our numbers, both positive. So on the top, we should have x plus 2 and x plus 3. And then on the bottom, with 9 minus x squared, again, same deal. We should be able to put this one into a box as well. Should get 3 and 3 to get 9, and then minus x, and then plus x to get negative x squared. And then that should work for our bottom there. So x plus 3, and then 3 minus x. So this should help us solving with some of the things that we're looking at. So first, domain. We want to take our denominator and set it equal to 0. And anything that is equal to 0 is not a value in the function. So if we have x plus 3, we want to solve, and we also want to solve for 3 minus x. So x is not equal to negative 3, and additionally, x is not equal to positive 3 if we move that one over. So our domain is all real numbers, excluding x does not equal 3, and x also does not equal negative 3. Second, for holes, we're looking for similarities on both the top and the bottom. So here, same thing on the bottom, same thing on the top. So we have a hole where x plus 3 equals 0. So what that tells us is after subtracting 3 from both sides, we have a hole at x equals negative 3. So a good piece of review from yesterday, looking at domain and looking at holes. So the challenge is going to be when we see examples of expressions and equations that get a touch bigger with some of the factoring is going to be a little bit more challenging for us. And we can use some of the same methods that we've had throughout the course to look for some of those factors that we might be able to take out and eliminate here. So going through here, we can jump into our next question. And I'm going to have us take a moment and see if we can set this one up and solve it as well. So some key things for our second equation here are actually going to be falling back on some of the factoring that we've done in the past for solving our top. So we do have a couple of values here that will help us out with discovering what these intercepts are and maybe what some of our factors might also be. So for the top, because we have to the third power, we actually do want to go back to our steps where we have plus or minus 12, plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 4, and then plus or minus 3. We want to run those all through our calculator and see which one of these terms is going to give us an intercept that we are able to cleanly factor out. And if we see one of those terms as something that we can factor out, then we can start using synthetic division, and that might help us find something that we can see. So in this case, if you do run these through your calculator, you should get 2 as an answer for one of them. So we can use some synthetic division using 2. So what that's going to tell us is if we have x minus 2, because we factored the positive 2 out, we should have x squared minus 6 as our second term on top if we factor that. So actually a pretty cool application on the top of factoring a pretty challenging question just by using some of the methods that we had used to solve for factors and intercepts in the last couple of months. On the bottom, x squared minus 4, this is fortunately a nice one. So we can just, I'll do it off to the side here. So if you need to see this in the box, x squared and 4, x and x, 2 and negative 2, and then we'll see x minus 2, and then x plus 2. So by doing this, the factoring on the top is going to help us out with finding what might or might not be a whole. And then on the bottom, we can use that to solve for our domain. So for our domain, x minus 2, x plus 2, not equal to 0. So we'll get x does not equal 2, and x does not equal negative 2 for our domain. So all real numbers except for that. And then for our whole, we can see x minus 2 is repeated on both the top and the bottom. So we can have a whole at x equals 2. Because if we set x minus 2 equals to 0, we'll get that answer of x equals 2. So these are the two things that we're looking for here for our second one. And again, the key to solving this one was listing out all of those possible real roots and then just putting it into synthetic division. And that allows us to fully factor the top in a way that we might not have known before starting this course. So the next part of this is moving on to our backside here with a couple more notes. So y-intercepts, these are any point on the y-axis where x equals 0. And then for x-intercepts and for our zeros, any point on the x-axis where y equals 0. So in a rational function, it's always at the factor in the numerator when in lowest terms. So some examples down here, basically what we can do is utilize the strategies that we have up here. So setting x equal to 0 or setting y equal to 0. And that helps when we are looking for x-intercepts and y-intercepts. We also want to make sure we're still looking for the domain, looking for any holes, and just kind of holistically looking at everything that we can see on our graph here. So for the first one, we can practice y-intercept first. So to find a y-intercept, we want to set x equal to 0. So for our function, we have y equals 2x squared minus 7x plus 3 over x minus 7. We want to take each of these x terms and put a 0 in its place. So for each of these, the first one, 0 squared is 0, so 2 times 0, that cancels. 7 times 0 also cancels, so we're just left with on top 3, and on the bottom 0 minus 7 is negative 7. So for this, y equals 3 comma negative 7. So our ordered pair for the y-intercept is 0 for x and 3 over 7, negative 3 over 7 for y. So all we're doing for this one really is just plugging in 0 and seeing what's left over. Gets a little bit more complicated for the x-intercepts. So for x-intercepts, we have to set y equal to 0 and then work through and solve. So what we're looking for here is kind of just working through the same process and the same steps that we did before, just finding an answer for our bottom terms here. So a couple things to keep in mind. we have to make sure on our domain that we don't have 0 on our denominator on the bottom. So we're going to be looking for basically anything that can factor on the top first, and then after we go through our factoring on the top, we can continue to solve and see if anything cancels out, and then see if anything on top does in fact work for us. So first steps first, going through our factoring on the top. So you can use box method, you can use quadratic formula. There are a bunch of different options here for really anything that, any strategy that you prefer for these. So if you are someone that has the quad form in your calculator, you'll be basically solving the top of this one almost immediately, getting some of those answers there. But if you like to do it by hand, again, totally fine. So just going to break this one off to the side here. So like I said, if quad form is your preferred way, then definitely go ahead and use that. But if you like to do these boxes by hand, feel free to use those as well. And again, these ones with the leading coefficient being a little bit bigger do take just a touch longer to do, but again, no issues there with our factoring. So on the top, we get 2x minus 1, and then x minus 3. And on the bottom, we just have x minus 7. So all this is still equal to 0. So again, we don't want the denominator to be 0, but anything on the numerator that is 0, all of that is okay for us. So something that we can do now is just kind of work through what we have and set our top terms equal to 0. So 2x minus 1 equal to 0, and then x minus 3 equal to 0. So by doing this, we'll get 2x equals 1, and then x equals 1/2, and then we'll also get x equals positive 3. So the two x-intercepts that we have are 1/2 and positive 3 for our function here. So again, if we keep going, what we're going to continue to do is look for our domain. So domain takes our denominator and make sure that that doesn't equal to 0. So we're going to say all real except for x does not equal positive 7 as well for our domain. And then here we don't have any holes on this function because there's no factors that are in common on the top and on the bottom. So a bunch of strategies here solving for today with factoring, with finding x-intercepts, with finding y-intercepts. So as long as you're following these steps and you remember some of those old strategies that we used, you're going to be in great shape. And if you're having a hard time with some of those old strategies and factoring when it gets bigger, don't be afraid to ask for help. And that's why we have our peers and our teachers around us. So a lot of methods for support. But for today, just going through and doing some solving, and we should be all good to go. So if you got questions, as always, feel free to